Hey guys, so this video is going to be over monohybrids or Punnett squares that have to do with one trait. Before we do that though, let's talk about Gregor Mendel. He's known as the father of genetics, and we talked about him and we mentioned that his experiments and his research was done by using pea plants when he was in the monastery that he lived in, okay? And all his research became known as Mendelian genetics, which is genetics where heredity is not a blending of traits. Okay, so if, for example, what I mean by that is if your dad has black hair, your mom has blonde hair, well, according to this type of genetics, Mendelian genetics, you would either have black hair or blonde hair. You wouldn't have something in between. But we know that that's not true. Today we know that there is blending of traits, and you could actually have black hair, blonde hair, or brown hair, or a darker blonde or a lighter blonde. So there is blending of traits, but the type of genetics that we'll talk about in this video are just Mendelian genetics, where you're either going to have the dominant trait or the recessive trait. Okay. Now to solve our Punnett squares, we're going to follow 4 steps or 4 rules. And the first one is to determine the alleles of the parents. That's to determine what letters are going to be used to represent the parents. Okay. The second step is to determine the gametes. What letters can that parent give off to his offspring? Okay, and these 4 steps are really easy in monohybrids. Step number 2 is the one that gives some students some challenge when they're doing like hybrid crosses. Okay, so we'll go through all of them. But the third one, going back to the steps, is to find the combinations. This is when you set up your Punnett square, you actually do the Punnett square. Then number 4 is to determine the ratios. And you can give me the ratios in decimals, percentages, or just by numbers. Okay, and we're going to be talking about genotypic and phenotypic ratios. Okay, generations, we talked about generations, and we said that there's 3 generations that we're going to talk about. The first generation is the P or the P generation, which is the parental generation. That's parent 1 that crosses with parent 2, and when they have offspring, then they produce an F1 generation or an F1 offspring. So that would be the F1 generation. Now in plants, if you cross the F1 with the F1 generation, okay, you produce, you guessed it right, an F2 generation. So if you look at, and it just depends on who you're looking at, what generations you're looking at. So if you're looking at your grandparents, well, this would be your grandparents, parental generation. Then your parents would be the F1 generation. Then the F2 would be you, because you're the 3rd generation here. And again, that's just some terminology that you might see in some of the questions, so you need to be aware of what they're telling you. Okay, all right, then let's start with our monohybrid crosses, which is just crosses where one trait is used. And the way the monohybrid crosses look is just a 2x2 Punnett square. Okay, and that's a monohybrid cross, a 2x2. So you have each square represents an offspring, so in a monohybrid cross, you can actually predict the outcome of 4 offspring. Okay, one trait. What I mean by one trait is that you could look at the color of hair. Okay, and the color of hair would be, let's say we use 2 letters, big B for black hair. Okay, and we could also use little b for brown hair. Okay, and that's one trait. We're looking at one trait, color of hair. We use 2 alleles to represent that trait, but it's only one trait. Okay, so let's look at our example real quick. Okay, the P generation, so that means the parental generation of pea plants consists of a big B, tall plants, and little b, short plants. So both on parental generation, you either have a tall plant or a short plant, and they're both homozygous. One dominant, one recessive. Okay. Tall is dominant over short. And the problem says cross a homozygous dominant and a homozygous recessive plant. So let's go through our steps and we'll set up the problem. So the first step is to identify the alleles of the parent. Well, we know that parent 1, okay, this one, we'll go with that one as parent 1, is homozygous dominant. So that means it's going to have 2 identical alleles, but the dominant alleles. That one is going to be crossed with a homozygous recessive, so that means the alleles are going to be recessive, identical, but the recessive ones. Okay, so now we know both parents. That's the cross we're going to do. Second step is to determine the alleles that parent can give to the offspring. Well, parent 1 can give a big B or a big B. That's his only options, right? Parent 2 can give a little b or another little b, and that's called independent assortment. But that's where that's how the only alleles or the only gametes that this parent can give, okay? And it's independent. It's just random, okay? Once we know what the gametes parents can give, then we set up our Punnett square. We know this is step number 3. And we know as a monohybrid, we're only looking at one trait. We're looking at the size of the height of plants. So we know it's going to be a 2 by 2. And it doesn't matter where you put parent 1 or parent 2, but in this case, we're going to put parent 1 on the side. So we're going to put big B, because that's the two alleles that it can give. And we're going to put parent 2 on the top, so it's going to be little b, little b. Okay, so once we set up our Punnett square, then we make our cross, and that gives us this types of offspring. Okay, so now we can actually go back and do step number 4, which is to identify the genotypic, okay, genotypic ratio, okay, which has to do with how many combinations of, or how many different genotypes there is. Well, how many big B, little b are there? Well, there's 1, 2, 3, 4. So this genotypic ratio is easy. You can just say 4 big B, little b. Or you can also say 100% big B, little b, okay? The other ratio that we need to talk about, or we need to find, is the phenotypic ratio. And the phenotypic ratio has to do with the traits or the characteristics of these organisms. Well, we can see that this one, by using another code, this one is tall, this one is tall, that one is tall, that one is tall. So that means we have 4 tall plants, and that's our phenotypic ratio. So that's going through the 4 steps that I gave you earlier, okay? So let's go through another example, that way you can get more practice. So the next example says, height alleles in roses, big T's for tall, little t's for short, and it tells us to cross 2 heterozygous roses and show the phenotypic and genotypic ratio. Well, we know that the 2 parents are going to be heterozygous, and that's step number 1. And heterozygous means you have 1 allele or 2 different alleles, right? Big T, little t, because it's heterozygous. Number 2, we're going to identify the gametes. So this parent, okay, can only give a big T or a little t. This parent can give a big T or a little t. So, like I said, monohybrid crosses are very, very easy. Okay, now we set up our Punnett square. This is step number 3, and we put our gametes on the side. So it doesn't matter where you put them as long as you keep both alleles together. Okay, and then we'll put this one on the top. So this is big T, little t. We make our cross. So this would be big T, big T, big T, little t, big T, little t, little t, little t. Okay, so that's our combinations. Then from here we can actually get our genotypic ratios and our phenotypic ratios. So GR stands for genotypic ratio, and we can say that there is 1 big T, okay, 2, there's 2 big T, little t, and there is 1 little t, and that would be our genotypic ratio. Okay, that's just how many of those type of genotypes there are, so we can just say that's our genotypic ratio. Then we can find our phenotypic ratio, okay, and we just got to look at the physical characteristics. This one right here is tall, this one right here is tall, this one right here is tall, this one, nope, that one's not tall, so we got to say that we have 3 tall, and then we put our ratio there, and this is our 1 short. So those are our phenotypic and genotypic ratios. Okay, all right, so those are the 2 examples I wanted to go over with you. Okay, and then I'm going to go over one of the examples in the homework. So let me pull that up. All right, so here's the problem. We'll go over number 1, and it says the P generation P plants consist of a big T, tall plants, and little t, short plants. Big tall is dominant over short, cross a tall plant with a short plant. Well, that's the same exact problem we had, right? And we said that this is a tall plant, this is a short plant, okay? And we know that because it tells us right here what they consist of. And when we set up our Punnett square, again, you put parent 1 on one side, parent 2 on the other, and you do your cross, okay? And our genotypic ratio would be 100% or 4 big T, little t, Okay, our phenotypic ratio is how they look. It would be 100% tall. Okay, and that's what we get from the offspring. We get 4 offspring, and that's the information we get from them. Okay, now let me bring that up. Sorry, I took it off. All right, so there is the information. Okay, so from here, if you go to number 2, as you do your homework, they're telling you to cross 2 F1 generations. Okay, well, we know that this is the P generation. So what the offspring of the P generation is the F1 generation. So you got to pick 2 of these. Okay, big T, little t, big T, little t. That's your F1 generation. You set up your Punnett square. Okay, you do your cross, and then you keep going. Okay, so let me know if you need any more help. I hope this helped.